This is for Year 11 methods. We're going to look at exercise 9E. We're going to look at probability tables, or known as Carnot maps. You would have learnt this in Year 10 methods pathways, but it's always good to revise. Now, the premise of a Carnot map is, in case we do not want to draw a Venn diagram, which is shown here, we can actually alternatively draw something called a probability table. So the idea of a probability table is it's a table of intersections. So what I mean by that is if I have the event A, then I have the event B, then you'd either have A, not A, B, not B. Okay? And in these boxes, you fill in the intersection. So the probability of A and B, it goes here. The probability of B intersection not A, in other words, that means B only, goes here. The probability of not B A, meaning A only, goes here, and the probability of not A and not B goes here. Okay? And the unique thing about a probability table is that if I add the two columns, well, if I add the column total here, then I get the probability of A. Okay? If I add the total here, then I have the probability of not A. If I add the rows, I get the probability of B, and I get the probability of not B here. And if we're talking about probabilities, then the total of the column and row at the end sum up to 1, because that's the total probability. Now, these tables can either be probabilities, so it can be decimal values, or it could be cardinal numbers. So you'll notice that in some of the problems, they're either asking for probabilities or in cardinal numbers. So you've got to determine which one is given. Just know that number might not be 1. It could be the total of whatever sample you've taken, the probability. Okay. So another way of saying this is it could be the count. Okay, it could be the count of whatever the experiment is. Okay, so 40 students were surveyed, then the total here will be 40 instead of in terms of probabilities, it's 1. If you want to convert these to a number table into probabilities, then you just divide it by the total to get the probability. Okay, we'll do some examples. So this is a nice summary of what I've just explained there. Now let's go through 9E. If question 1, so if A and B are events such that probability of A equals 0.6, probably A in section B is 0.4, B only is 0.1, find these values. Okay, so the first step is let's draw a probability table. Okay, so you have 4 squares and you have squares, extra squares over here. Okay, and you label that, let's just label that A, not A, B, not B. And we're given the probability of A, so the total of A is 0.6. The A in section B is 0.4, so A in section B is 0.4. B only, so B only is 0.1. Okay, so, and we know that these are in probabilities, so it sums up to 1. Okay, so these are the values I'm given. All I need to do is find the other values. I know this and this add up to this value, so when I add this and this together, I get 0.5. I know this and this add up to 1, so that has to be 0.5. I know this and this have to be 1, so that has to be 0.4. 0.3 plus 0.1 is 0.4, and 0.2 plus 0.3 is 0.5. So you can see that once I've got the values filled in from the data given, I can fill in the rest because I know that these sum up to the same rows, and these sum up to the columns, and we know that in total the n row and n column sum up to 1. Okay, so let's answer the question. 1A, it's asking me for A only. So A only, I look at the table. A only is not A only, so A not B. So part 1 is 0.2. Okay. For B, probability of B, really simple. I just read the row, the end of the row, the total of the row. So it's 0.5. So I'm talking about this row, 0.5. C, probably not A, not B. Not A, not B, 0.3. And D, probably A union B. Okay, this one's a bit tricky. And I'll tell you why it's a bit tricky. A union B is the probability of A plus the probability of B minus the intersection. The reason that is because if I calculate the total here, and I use the total here, so I'm using these two values, then I've counted this number twice. So it's like a Venn diagram where, you know, if you got A and B, then the probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. Okay, same idea. Like I said, this is like a Venn diagram presented in a table form. So the rules for Venn diagram still apply. So the probability of A union B is the probability of A. What's the probability of A? Probability of A is 0.6 plus 0.5. We automatically know there's something wrong here because 0.6 plus 0.5 is 1.1. That's not what we want. That's greater than 1. That's nonsense. So we need to know that we need a minus 0.4. So 1.1 minus 0.4 gives me 0.7. Okay, so that's how you do D. Let's go through question 4. So if E and F are such events such that E union F is 0.7, E intersection F is 0.5, probably not E is 0.55. Okay, so find the probability of each one. So this one's a bit more tricky because we're given information that needs to be, well, we need to perform a bit of work before we can get our answers. Okay, so we've got drawn too many squares there. We've got E, not E, F, not F. So the hard part is identifying what you have and, you know, how to fill in the table. Okay, these are probabilities, so you'll sum up to 1. Now I know that E intersection F is 0.15. That's given. We're also given E union F is 0.7. We might deal with that a bit later. We'll use not E is 0.55. So if the probability not E is 0.55, then the probability of E would be 0.45 because it's a complement, right? So probability of E is 0.45. Not E is 0.55, which gives us 1. And I'm also given E union F is 0.7. Okay, so do you remember the formula? Probably E union F in a probability table is probability of E plus the probability of F minus the probability of E intersection F. So because in this table we're interested in like the intersections, we need to find what the value is. We know E union F is given to us, it's 0.7 equals the probability of E. We worked it out, it's 0.45 equals 0.45 plus the probability of F. Okay, we don't know what the probability of F is. We don't know what the probability of F is. So, to find the probability of F, we need to work this out, okay? So, I know that if I call this letter A, I know that the probability of F, we don't know what the probability of F is. So the probability of F is, we want to work that out. Okay, we actually have E intersection F. So 0.7 equals the value of E, which is 0.45, plus probability of F, we don't know what the probability of F is, minus E intersection F. E intersection F was given, so it's 0.15. So if I solve this, 0.85, so it's 0.85 minus 0.45 equals the probability of F. So we should get should get 0.4. Okay, we should get 0.4. So probability of F equals 0.4. So probability of F is 0.4. 0.4 over here. That has to be 0.6. This has to be 3.3, 0, and this has to be 0.3, and this has to be 15.25, so 0.25. Okay, now that was the hard work because we just need to fill in the table. We can find the probability of E. The probability of E is 0.45, so A is 0.45. The probability of F is 0.4. The probability of F only is 0.25, and the probability of E union, not E union F. Okay, so for not E union F, you got to do this. Probability of not E union F is the probability of not E plus the probability of F minus probability of not E intersection F. Okay, so probability of E not E is 0.55. The probability of F is 0.4 minus the probability not E union F. Yeah, 0.25. So that's 0.95 minus 0.25. Okay. Minus just so you should get 0.7. Okay, so that's 0.7. Okay, so that's how you approach this problem. There's a bit of a trick over here, but that wasn't too hard to figure out. Okay. Alright, I will do question 8 and 11 in another video.